Hello, everyone. Good evening. Welcome to the African Medical Scholars of Professional Network Professional Development Mentorship Program. This is the first section for the Tech and AI track. Today, we'll be starting with the introduction of analysis and just debunk that the flyer says part two. So the plan is that our speaker tonight will take part one, while the other speaker that was scheduled for part one couldn't make it yesterday will take part two on Saturday. So tonight we have our trainer. Tonight we have our trainer, Mr. Agada Samuel Febuche, who is a radiographer, a data analyst, and an aspiring machine learning engineer whose work sits at the intersection between healthcare, data, and artificial intelligence. Mr. Samuel is also the overall winner of the AI and Data Literacy Challenge in 2025 and currently serves as the planning committee of Medics in Tech. He has earned multiple certifications in data science, AI, and was trained as a health data analyst. Mr. Samuel continues to explore the transformative role of machine learning and artificial intelligence in healthcare and beyond. Ladies and gentlemen, let's stand ovation for Mr. Samuel Ifebuchi Agata. Mr. Samuel, the floor is yours.
All right. Thank you so much, Mr. Chijoke. Thank you for the wonderful introduction. Good evening, everybody. Can you all hear me?
Yes, please.
All right. I welcome you all to tonight's story on this data foundation. Because I'm about to share my screen now so that we can continue. Please confirm if you can see my screen.
Yes, we can.
Yes, please.
All right. So good evening once again. Just like Said has already said, my name is Agada Samuel Febuchi. So I'm here today to take you on the part one of introduction to data foundation and data analysis. So today we are going to just learn the basic data foundation, like what data is, the type of data, and how you can organize your data. So at the course of the lecture, and if you have any question, you can just write it out somewhere, or you can put it in the chat, or you can wait after the lecture, then you can ask your question. So it's going to be, just like I said, the introduction is the foundation. So we are just going to, it's not going to be something that will be hard to understand. I will try as much as I can to make it very simple. And this particular topic is not a hard topic. So data, just like we have been hearing data, but you'll be thinking data is something big. But every day, even today, all of us here, we have made use of data. We have interacted with data. We have produced data. We have recorded data. We have even measured data today. Because you're checking your time, you are checking data. Data is just anything that can be recorded, a fact or measurement that can be recorded or that can be observed. So is just what we do day to day Just like I said, you checking your time, the time you are checking is a data. It can be something that is written down or recorded. So, for instance, in our day-to-day activities, our name, just like your name, is a data. If you measure your temperature, is a data, the reading you are getting. Your age is also a data. The picture you take, time, the voice notes you make, or password, your heart rate, all of them are data. Because all these things, when you gather them, you can analyze them, and the analysis can give you a particular result, a fact that you can use to make predictions. In the hospital, the blood pressure you are measuring is the data. Because when you check the blood pressure of some patients, you can use it to arrive at a particular result that so class of patients may come up with heart disease, heart failure. The patient's ID that you are always putting in is a data. The X-ray results you are producing is a data. The reports that the radiologists are reporting is a data. So all these, our day-to-day activities, all these things that we are generating, they are very important. That's why we need to be very careful when imputing data in our everyday day-to-day life. There's difference between data, information, and insights. Data are just a raw fact with no context. While information is a data that have meaning, it has been organized to have a particular meaning. And insight is the conclusion that you have drawn from the organized data. For instance, if somebody, as a businessman, on Sunday, you make so sales on Sunday, then on Tuesday you make so sales. Let's say, for instance, example that I have here, as sales on Monday is 500, then on Tuesday is 320. These are information. But if you just have the numbers, you have a data, but the data does not have a particular meaning. But when you now organize it into a meaningful fact, it is now an information. And when you draw conclusion from the information by checking that, that the sales I made on Tuesday is lower than that of Monday, then the conclusion you can make, or the prediction you can make from this thing, is that sales drop on Tuesday. Let's go down to healthcare, because I believe we all here are healthcare professionals. So, for instance, in hospital, that you have a list of temperatures. It's just a data. After measuring those temperatures, they are data. But a data, just like I said, a data with meaning is an information. To checking a particular patient's temperature and noticing that at 8 a.m., the temperature of that particular patient is 98.6 Fahrenheit. 12 p.m., the patient is having 101.2 Fahrenheit. By 4 p.m., is increasing. So the information here is that you have a data, and the data has a meaning because you are relating it to the condition of the patient. Then for you to look at the data very well and drive a conclusion from it, that's an insight. From what I just said, we notice that the temperature of the patient is consistently increasing, which may be due to infection, or that the treatment is worsening. So why data matters is that it tells us stories. For instance, in business, it tells us which stock is going down, which one do we need to buy more, which one are the customers requesting. which one should we stop buying, or which one should we stop producing? Maybe after production, all the time, that particular product keep on expiring because customers are not buying it. So you need to analyze the data you have and know which one to focus on more. Then in something like government, it determines where the government can build schools. Say, for instance, after conducting census, you get the number of people living in a particular place, or there's an endemic disease, or there's an outbreak. It's all those information that they gathered that will help them to allocate resources. Then in our day-to-day life, data has, for instance, in our bank, it tells us how much we have, how much we can spend, how much, a lot of things. It helps us to make day-to-day activities. So let me just bring it down again to our healthcare, because if I'm explaining it like this, it may sound so abstract. Because if you understand the way AI works, then you will know that all these basic day-to-day things that we are doing, that we may be wasting data, but we don't know. Like you may go to hospital, you see shelves that contain patients' record, wasting. These are resources that we are wasting. So how AI works, from AI, like the AI that makes prediction. I don't want to go into generative AI, but predictive AI. How it works is that AI is as good as the data you give to the AI. So you gather data, you make sure that the data is clean. So I think is in the second part of this lecture that we will tell you how a consistent data look like. The data that does not have duplicate, that does not have missing values, and all that. So after gathering those data, you make sure that the data is clean, because the quality of the data you give to the AI determines the quality of the outputs it will give you. So let's say, for instance, that we want to train our machine to understand a pattern, because AI works well with pattern recognition. That's why the field of medical imaging is one of the fastest growing field in machine learning, because it deals with pattern, and machines are good in identifying patterns. Let's say, for instance, we want to train our machine to be able to identify patterns of tuberculosis. So we gather as much images of tuberculosis as we can, and we make sure that those images, that they have consistent format. Like if you are using a particular pixel size, we should maintain that pixel size, standardize it, and all that. Then after gathering those particular images, then we teach our model that this particular image, we label it that all these images are tuberculosis images. So if we want our model to be able to differentiate it from pneumonia, you can gather plenty pneumonia images also, label it that this is pneumonia, then allow the machine to see those data. The machine will learn from the pattern that if you see so pattern, that is for tuberculosis, you see so pattern, it's for pneumonia. And after teaching your machine, then you can be able to bring new data that the machine has not seen before. And the machine will use the pattern that the machine has seen before to make prediction. This is the basic predictive AI that we can produce. There are other ones, we call this one supervised learning. There are other ones unsupervised, in which you can just gather the tuberculosis and pneumonia images with no label. You did not tell your computer that this is tuberculosis or this is pneumonia. Then you give the data, a clean data to the machine, and then the machine will be able to do segregation to separate that of tuberculosis, the pattern that look alike, to separate it from that of pneumonia. So all these are just a foundation of how AI makes use of data. So the images we are producing in radiology department is a very big data. Medical imaging, just like I said, that the reason why AI is booming in medical imaging is because of that pattern recognition. And in medical images, lots of data are generated every minute. And AI depends on data. So the quality of the data determines the quality of the output. So if I'm saying data, our mind should not go to something so far, something that we interact with. The patient's ID you put in, the name of the patient, the age of the patient, because you can use all those things to come to a particular conclusion. The reports that the radiologists are reporting, the images that they are constantly generating, all these are data. So these are examples of why data matters in healthcare. Say, doctor can read a lab result to arrive at a particular diagnosis to make to prescribe treatment. So these are just a summary of all that I've been saying. Then where does data come from? So just like I said, data come from all these things that we do day to day, every day, our everyday activities. So if I say that the time you check all the time, or your location at a particular place in time is a data. You may be thinking, how is it a data? But if you check your routine, your daily routine, that at a particular period in time, so time that you may be in this place in the morning by 7, you may be in your bed. By so time you may be in the hospital. By so time you may be in school or something like that. We can use those time to make a prediction of exactly where you can be at a particular period in time. So these are just data. So data, if you hear data, don't think it's something that is big. You generate data all the time. In hospital, the notes that the doctor writes while clocking the patient, they are data, because with the notes, you can use it to come to a particular conclusion. Maybe it's also patients that are complaining of pain at the neck that is radiating to the hand. You know where it's coming from. It's because of gathered data that they can tell you that this pain that is coming from the neck like this may be coming from the brachial places. And then they will tell you to do cervical X-ray. That the pain is at the lower or waist pain radiating to the leg. These are data that they have gathered, and they have come to a particular conclusion that when you have so pattern, that these are the likely cause. We will use those data over a long period of time to make a prediction. The temperature you check, you generate from the machine, the name of patient that you type, all these are how you produce data. So we have different data types, and the reason for having different data types is because the way we handle each data differs. So you understanding the data type will help you to know how you can tackle this particular data to arrive at a particular conclusion. Your main aim is to look at the data, then transform the raw data into an insight, like from raw data to information to insight. That's just your aim. So there are two big, we can classify data into two. We have the quantitative data, which anything quantity is talking about numbers, and we have the qualitative data. Quantitative data are those data that you can count, you can measure it, or you can calculate it. Just like your age is something that you can count. Temperature can be measured, blood pressure can be measured. All those values, all those data that are in number, they are quantitative. While qualitative data are categorical data, it helps to classify the qualities or the category. For instance, if I say male or female. You cannot, it's not a number, but it's a category of gender. So blood group, A positive, AB, and all that, they are category. So, and in this categorical data, you can even divide it into two. I don't think I put it, I don't think I have a slide, but it can be divided further into two. We have the nominal and we have the ordinal data. So nominal data are naming data. They don't have order. So just like you having blood group A, AB, O. So these blood groups, they don't have order, which one is higher than this, which one is lower than this. They are nominal data, they are just naming data. What ordinal data are the data that has order. Like if a patient reports that the pain is severe, we have mild, we have moderate, we have severe. These are order. If you're answering questionnaire, you will see agree, strongly agree, all those order, they are ordinal data. I hope you are still following me. Can you still hear me?
Yes, please.
All right. Thank you. So these are quantitative data. They are the data that are measurable, the patient's age, the weight, the height, the blood pressure, and all that. All those data that are in number, that are measurable, that are countable, are quantitative data. So in quantitative data, one thing I've told you that the type of data will determine what you do with it. So for instance, in quantitative data, you can calculate, let's say, the age of patients, and after calculating the age of patients, you can get the average age. That the average age of patients is this. But in categorical data, you cannot get the average. You can get something like the mood. The mood are the one that has the frequency is more. They have more occurrences. So, but you cannot get the average of that particular, unless you count, is the type of data determine what you do with it. That's what I just want to explain. Then these are the example of qualitative data. So I'm just rushing so that I'll be able to finish it, even though it's just like in introduction, it's just like a summary so that you understand what data is. Then when we enter the second part of it, then they will tell you how you can organize your data, then introduction to data analysis. And then in our next one, you can be able to understand when we enter data analysis in Excel, SQL, Python, and all that. It's all these basic things that I'm telling you I'll be making use of day to day. And then from there, you will see the application of all that we have been talking about. So there are other data types like date and time. It's very special because the way you treat date and time is different from the way you treat other data. Date and time, it can be in different formats. Even in your phone, you can say the format of your time can be year, month, day. YYY, MM, YYYY, MM, DD. It can be in form of January, maybe 15, 2000, depending on how you want it. So the data can be formatted in different ways. And the reason why this data is so special is that the way you tackle other data, like adding of data and subtracting of data, is different from how you treat date time. So date time is also one of the data type that is very important in healthcare because it gives us a lot of information about the patient, about the hospital, about the treatment. So there's what we call admission rate. So let's say that a patient, we can calculate the number of hours that the patient stays in the hospital, the number of days that the patient spends, and how many of them after discharge is coming back to be readmitted again. To the admission rate, the rate, if it increases, is telling us something. Maybe there is no adequate treatment to the patient. That's why they are relapsing. That's why they are coming back again for readmission. So it gives us a lot of information about the treatment, about the hospital, about the patient's condition. So date time is something that we should be very careful, especially as we are going to start working with Excel. You don't treat date time like other data formats. Then we have the Boolean. Boolean are data type that are true or false. So in Python is where we make use of this Boolean very well. In Python, you start Python by knowing the data types, the integer, the Boolean, there are plenty data type, and understanding those data type will help you to know how you can tackle them. So data type, this Boolean is a yes, no answer or true or false data. So like asking if a patient has HIV or not, true or false. If a patient is pregnancy or not, diabetic or not, all those true or false, yes or no question in data, they are called Boolean. This Boolean, well, when we enter Python, we are going to go deeper into this Boolean to know how it works. Then we have free text, like unstructured, we call them unstructured data. So I don't think I have a slide for it here, so I will not go deep. When I reach there, I will tell you the difference between structured and unstructured data. The free texts are those texts, the observation written by nurses, the doctor's reports, the patient's feedback. So after every attending to the patient, some organization can try to get a feedback from the patient to improve the patient satisfaction. All these are data that you gather to improve how you attend to patients and to increase the patient satisfaction. They are data that you can work with. So we have images and media. The images you get from X-ray, from CT, from MRI, ultrasound, ECG, the audio recording, video recording, all these are important data that we should not joke with in healthcare. So this is a call for everybody. If you know the protocols, or maybe where you are working, they are not following the protocols of generating data in the hospital, just follow and do the right thing, because I've worked with a data that I was part of the people who compiled the data, and the data I suffered because it was very messy. So it was one challenge that I participated in, and we have to make use of real-time data of where you are working. So I have to just get a data from the database of my hospital, get X-ray images and work with it. And I saw the rubbish we have been doing, the rubbish we have been generating, where you are supposed to put patient ID, you skip it, where you are supposed to put all those skipping, all those things that you are supposed to fill. You are creating a messy data. So we should always follow the protocols so that it will help any experiment or any research that is to be carried out in that particular place. So it will make everything easy. So follow the right thing. Don't follow what other people are doing, what your colleagues are doing. Follow the right thing. Then a data that is not organized is very useless. Just like I said, in the shelves, in your patient's record in the shelves, those papers that have a lot of patients' record, they are not organized, so we cannot make use of them. So the standard way of arranging data is in spreadsheets. We all know spreadsheets that has rows and columns. So it's the standard way of arranging data. Even if there are a lot of data, the majority of data that are produced in healthcare are not structured in that way. They cannot be put into rows and columns. So the rows determines the features of a part of that particular data. Each rows, they have the same format. The column, the column determines the feature or the the variable. So they will have the same format. Like a column are those ones that are coming vertical in a spreadsheet. So each one, a particular column, it will contain the same data type. If it's age, you know that age is not is an integer, is a value, a number, it's not text. So in age column, all of them should be of the same data type. In diagnosis are text. So all of them should be of the same data type. These are the features of each of the patients. So they are those vertical, the one that is coming from up to down, uh, the vertical side of the spreadsheet. They are the columns, and each columns carry a particular information. Yeah. Just like I said, all data in a particular column must be the same. Age, if age is an integer, all data at that age must have a particular, the same data type. So the rows are the feature of that particular patient. They are the attributes, or they are the variables. Why, the columns. Why the rows are those horizontal lines in a spreadsheet. So it's a record of a particular entity observation. One row is an information, all information concerning, let's say, a healthcare, a patient, for instance. One row will contain all information concerning that particular patient. Another row will contain all information concerning that particular patient. So it's just like a complete entry of a patient information. So, and where the rows and the column intercept, it carries just a pieces of information, and we call it a cell. Just where the intersection of rows and columns is what we call a cell. So in our introduction to a cell, we will see all this thing. Then if you can see my cursor, you can see that we have columns. We have columns. This column is for patient ID, patient 001, patient 002, 003. This column is for name of patient. They have the same data type. They have the same data type for age, for blood group, for diagnosis, and for admission dates. These are in date time format. So this allows us to look at a particular feature of that particular patient. Like we can say, okay, patient 001. What's the diagnosis of patient 001? You can see that it's hypertension. These are the features of this particular row. Then I've explained all this thing. Then for these are rows. Rows are this horizontal one. It carries all the information about this patient 003. The name is Fatima. The age is 32. The blood group is B2, B positive. The diagnosis is pneumonia, and the date of admission is also. It carries a complete observation about a particular entity. So the properties of a well-organized data. Each column must have a clear name at the top, just like we have here. Each column, this particular column is for header. This particular column is for the patient's ID, the name, the age. Then all value in a column must have the same data type. I've explained it. It must have a particular identifier. This identifier is very, very important, because when we start dealing with databases, is using the ID, the identifier, that we can gather information. Because in hospital, we have hospital record, we have that of radiology, we have that of lab. So all these things, the hospital own is like an admin, where after registering and everything, the patient will get a particular ID. And it's that patient's ID that you can use to get information from the RIS, the radiology own. You can just type in that patient's ID to give all information about the imaging that the particular patient has done, the X-ray, the CT, in the lab own. So these are this ID is an identifier for that particular patient, and you can use the ID to gather as much information as you can concerning the patient, the lab, the medical imaging that he has done, the payment, the insurance company that is sponsoring the patient, and every other thing. So it will have a consistent formatting. Just like I said, each row must have a consistent format. So there must not be empty spaces, no missing value, no duplicates. These are properties of a well-organized table. Then we have what we call database. Database are just a collection of well-organized tables that are installed in computer or in a server. So just like I explained, let me use business for example. A particular customer can have order table, everything that the customer has ordered. It may have a product table, it may have a billing table. All these are different tables, but it's the same ID for that particular patient customer. The same thing as in hospital, we have the demographic that has the details of the patient in a particular system, because in hospital, modern hospital, the systems, just like when you come to radiology, we have the PACS system where we store all this medical imaging. In hospital, we have a system that, in a modern hospital, we have a system that link all patient information to a particular database. Database is where we gather the tables for all the patients in the healthcare. So in that database, you can pull out a particular patient and get every information concerning the patient. This will help us that even if we want to do small correction, like the change of number, you can just use the ID to change the patient's number, that the patient wants to change social number. Then it will reflect in all the tables of the patient in radiology, in lab, and all that. So database is where we store all our information about this particular patient, and it has an identifier that link the patients in other tables. So we can store the information in a local computer. We can also store it in data in server like cloud. So all these have their advantages and disadvantages. But most of the modern hospitals, we are moving from local to cloud, because cloud is something that even if anything happens to your local machine, you can still get back your information. So I briefly explained how these databases are linked. So you see that the table, they share common columns that act as the bridges. And then the patient table may have the patient ID. Then it may have the lab ID, and then those ID are linked together, that you can just press in the demographic table. You can pull out a particular patient and get all the information concerning everything that the patient has been doing in the hospital. So I think when we start working with data, we will understand this thing better. Then this will help us to avoid duplicates. It will help us to save spaces, because you will not be repeating patient information in everything you are doing. You just come, type in the patient detail, and then do everything you want to do. And if you want to update, just like I said, if you want to update maybe phone number, it will just be applicable to one. When you update something here, it will reflect in every other tables. Then it can also help us to query, to pull out information. We call it query. Pull out information about a particular set of patients. Like you can ask the database you can just organize it to show you the patients that are over 60 and their recent results. It can show you the patients that are male with diabetes, patients that are female, pregnant women with hypertension. So it will help us to make a particular query and to get what we want. So just like I said from the beginning that we have structured and unstructured data. Structured data are the data that we have in our day-to-day life, that those data that are in a table, rows and columns. So we can do a lot of things. We can search, we can filter, we can sort, and we can analyze, like a table that have the patient vital sign, patient demographic, and all that. But there are some data that are not structured like that. Like the pictures we are generating from radiology, they are not in rows and columns. So this one is not that easy to organize. You need a special something, a special software or a special method to be able to analyze it, organize it, to analyze it, and to make meaning out of it. So that's why you don't something like medical images. You don't put it in, let's say, rows and column. It will not make sense. But we have a way of organizing it and analyzing it, which we are going to do in our subsequent lectures. So these are just examples of structured data. We have the temperature, the blood pressure, the lab result, and all that. Then unstructured data are the images we are producing, doctors' notes, the nurse's observation, the patient's feedback. This one, they are not organized, they are not structured. That's why we call it unstructured data. The images, the reports that we are having, they are unstructured because they are not in rows and columns. Then, in summary of everything we have done today, we have seen what a data is. That data is any recorded fact or an observation. And when we can organize it to drive an insight or conclusion from it. So raw data are not of plenty use until when we transform it into an information that will give us an insight. So we can organize our data in table so that it can be analyzable, it can be useful, and it can be searchable. I've also looked at some of the basic data type. It's not exhaustive. We have other data types, but these are the ones that you need for now. We have the categorical and the quantitative, that is the quantitative and qualitative, that is the numbers and the categories. We have the datetime, we have the Boolean, we have talked about the unstructured one like text and image. Each of them, they have their different uses. They help, the way of analysis differs. The way you retrieve information from them differs. So you knowing your data type, we give you them, we tell you how you can analyze it, how you can query it. Query is just getting an information from it and all that there. So we have also learned how we can organize our data. That some data are the standard way is those data that are in tables and rows, tables that is in rows and column. And we say that we have database that link all the tables together using a particular identifier. So then all these data will help us, the database will help us to make sure that we don't have duplicates, that we can use a particular ID to query a particular patient's information. And when we update any particular information at any point in time, it will be reflected in other patients' information. So I'm going to leave you with this thing to tell you that the foundation of healthcare now is data. That for you to, you need to understand how the way the healthcare is moving from all this analog and is entering the digital. When I say digital, it's not just a digital, but it's going towards AI. And this AI, what is the backbone of AI? The backbone of AI is data. So you need to learn data. You need to learn how to analyze the data. You need to learn how to understand the data. And then this is the foundation of everything you need. Even if you want to do anything in AI, medical imaging, or AI in any area you want to do it, the data is the backbone. So for people that say they want to learn AI, they want to learn, you have to calm down and understand and learn data first. Because when you understand data, then you will have that foundation of building anything you want to build in AI. Thank you so much.
Uh, um, Thank you very much, Mr. Samuel, for a very insightful tutorial tonight. So this sharp Q&A session. If you have a question, you can drop your question in the chat box. You can unmute and ask your question. We're just going to give a couple of minutes for the question and answer session. Okay. I think there's no questions for now.
Hello, please,
So,
I have a question. Good
okay.
evening, everyone. Thank you, Mr. Daniel, for this insightful presentation. Please, I want to ask, do we mean that no? Because I know that in most hospital system here, we don't really have this digital data collection. Does it mean that one can put up a spreadsheet and be keying in this data by his or herself so that it can be used in AI? Because the hospital database may not really have this data in a structured format as you have presented to us.
Okay, it's one of the challenge that we're having in African healthcare is we don't have the infrastructure of generating and storing data. That's why you will go to some teaching hospital, you will see a pile of patient data in the shelf wasting. So, but when you come to developed country, they don't joke with data. So for places that don't have the infrastructure, it is good that they just start making arrangements on how to be organizing those data. But for you, if you are working with something like medical imaging and you have that your the console, all those data, all those patient information and the images you are generating data already. So they are being stored in your database. The console has a database. All those patient information, the X-ray you have done, the CT, everything, it is being stored in the database naturally. So it's for you to learn how you can retrieve those information from the database. So there are plenty ways to retrieve information from database. You can use SQL, you can use other method to get those information and make an analysis. So if you are a radiographer and you have your console, your desktop, where you type in patient data and then maybe you have a digitizer, then process the patient's X-ray and see the results on your monitor. You are already generating data. It's just what is left for you is to learn how you can query those data. I hope it's making sense. But if it's all this data like manual processing, uh, if you want to, maybe you want to do a particular research, maybe you want to map out some hospitals and centers and make a particular research, or maybe the occurrence of a particular, maybe tuberculosis, then you can just do it manually, but it will take you a lot of time by looking at creating a spreadsheet, looking at patients, but you are not going to get much information to train your model when it comes to AI, because AI in medical imaging is all about picture, is computer vision. So, but if you want to come, maybe you are working with World Health Organization and they want to know the endemic pathology, endemic disease in your localities, then you can use the lab, all those things, and then be writing it out if it's something that is possible. Then you can get the most occurring disease in your locality. So, but for you to work with AI in medical imaging, it must be something in visual. Medical imaging deals with pattern recognition. I don't know if I have answered your question.
Yes, sir, you have. Thank you very much. Then another question I want to ask is that you made mention about how one can retrieve this data for usage, especially for those images like in CT or in the digitizer and all that. I don't know if you're also going to take us through that. That would enable us to be able to do that.
Yes, yes. We are going to take you through that, how you can make use of databases. I think we are going to do it in SQL parts and Python also, how you can retrieve data from your databases. So just stick with us. We are prepared for it.
All right. Thank you very much. I'm grateful.
You are welcome.
Okay, Mr. Samuel, I think you have questions too on the chat box. Should I read them out or do you want to read them? Which one
You
works
can read
better?
them out. You can read them out for me.
Okay, okay. So I think Talkat are asking, is it proper to use letters and integers, that's letters and numbers as ID? So he gave an example. So you're running a scan and the patient scan ID is SC01001, where the SC represents the scan, the 01 represents the month, and the 001 represents the first patient. Is asking if it is a good way to organize ID, that's using both a letter and an integer.
Yes, it's a good way, provided you maintain the format. Just be consistent with the format so that if you want to query it, if you want to retrieve information, you just follow the format and get it. So it's a good way. So there in data type, we have, if you check your something like Excel, you don't have, when you want to check the data type, you may have number, currency, and all that, but you will still see general. General are the one that contain both text and numeric. So you can store it like that, or just maintain the format in case of if you want to query it the next time. Thank you.
All right. Do we still have questions? All right. Mr. Roland, you can unmute and ask your question.
All right, good evening, everybody, and good evening. Thanks for organizing such a meeting. I really appreciate. Sorry, I'm actually on the road. My question is this. Please, could you enlighten us on how subsequent we'll be having the classes, more like the days, so that we'll be able to like plan ahead. Thank you.
Okay. This is it, right? The days of the classes are a little bit unstructured, right? The reason why it's so is because of the resource people that we have. I think right now we have about, I think, 4 or 5 resource people on this track, and they are extremely busy people working as well. I mean, we saw what happened yesterday. The speaker yesterday was held in traffic, and we couldn't have the section, and she's still on her way back to her house even today. That's why we had to shift her section to Saturday. So, but one thing is sure is that any session that we're going to have, we're going to you are going to be like we're going to, and I don't know whether you're in the group. If you're in the group, It's going to be announced probably 5 days prior, 4 days prior at least, right? So you get prepared. So it's going to be based on this the resource people's schedule, right? So, and also apologies for our colleagues that are not using West African time zone, that are 2 hours or an hour ahead of us. It's just the sacrifice that you have to like pay. I mean, I've attended sessions that are holding in 1 a.m. I attended sessions in 2 a.m. I've even had an interview by 4 a.m. Right? So it's just the sacrifice. If you see it as worth it, then it's the sacrifice that you have to put into it. Right? Sacrifice you have to put into it. I don't know if I answered your question.
All right, no problem. Thank. Yes, yes. Thank you.
Yes, yes, you will be able to get the slide. So we're trying to see, especially for this track, because subsequent sections are going to be built on previous sessions. So we're trying to see if we'll be getting the recordings as fast as possible. So we plan to get all the recordings we've had so far in other tracks. This weekend, it should be up before Sunday, or latest before Sunday rounds up. It should be up on our YouTube channel, so the link should be shared. Then subsequently, these sections will be trying to make the recordings available before the next one. So that way, we can go over the slides and go over the section again if you need to grasp and anything, right? So yeah, you're going to get the slides. In the absence of no other question, and first of all, I want to thank you, Mr. Samuel Ifebuchi, for such an insightful section and such an insightful and fundamentals too. And basically because you had to prepare this within in less than 24 hours, right? I had to reach out to you yesterday night because of the glitch we had yesterday. We don't take it your sacrifices for granted. I know you are born out from work and all. Thank you very much. Thank you very much. Thank you very much. We really, really appreciate it. Thank you very much. And Mr. Samuel has been with us on this from the preparation, like the whole PDMP program, right for the preparation, and he's actually the one spearheading the whole Tech and AI track. Thank you very much, Mr. Samuel. Thank you very much. Yeah, so we also want to make an announcement, right? So in as much as I mean this whole program, in as much as the organizers are pouring a lot of resources, a lot of code mailing and text and messages to get ample people on this track. The only thing we ask for participants is the seriousness to see it as worthwhile. One, to see it as worthwhile. I mean, some tracks were actually, I think fellowship and advanced training track was on is on hold because of we're not seeing much vibes from people that registered on that track. So you can't invite speakers and they leave the thing they are doing and they come to pour knowledge, and the people that want to receive the knowledge are not showing ample seriousness. And so that's one of the things we are asking. I mean, in meetings, we're not supposed to be reminded, oh, join the call and record the group, oh, please join the call. Right? I think if you see it as worthwhile, you should make out time for it and you should join the call, you should do the assignment. And this is going to be, I think, from the next sections, they're going to be assignments and stuff because we're trying to make it as practical as possible. Reason being that there are other programs that are going to come up. I think there is Swim, there is Connexing towards, I did Connexing last year, I think around June, July. So, and most of these programs, if you don't have at least basic knowledge um, of these things, you tend to suffer, right? I'm currently in Spark program and it's hell, right? It's hell because of fundamentals. So we're asking for the seriousness. At least if you get these fundamentals here, you go to more advanced programs and you even increase your chances of getting in those advanced programs, right? Where you can be able to like practicalize what you've learned. Then secondly is please if something is dropped, so each track, so this is like how will I put it? It's a train coach, right? Everybody's helping everybody, right? So each track is organizing something and needs the help of the other track should be able to work with. So currently, there's a research questionnaire that is currently flying. We're going to post it this night in a track group. Please try and fill those questionnaires, right? Try and fill those research questionnaires. So one of the visions we have for ARSP and COM 2027 is that we should be able to have people from this organization go for sponsored conferences within Africa and beyond Africa. And to do that, we have to do ample things, right? We have to like start moving from just organizing meetings to actually showing practicality of the things we are learning, right? So the research questionnaire is up. We're going to share it in the group. It's a sub-Saharan African study, which is a very large study. We need about over 500 participants, and we've not even gotten up to 50, right? That's how bad it is. Please, when the questionnaire is shared in the group, please just do the justice to just fill it. It doesn't take time. I think 20 minutes, 30 minutes is really, even a lot. You are done and you submit it, and that's it. It's strictly confidential. There is no name attached to it. There's nothing attached to it. Just that, right? Then, sorry, I think I should, sorry, just permit me to just stop this recording. Just to do my screen. Stop recording. Okay.